Hello, everybody. Good morning. I hope everybody is doing great. I see very less strength here today. Right, I have only 6 of you, I guess. Right. Okay, no problem. Okay, guys. Did you write a test recently from Epsilon?
Yes, sir.
Okay. Can you give me the question paper? Can we discuss the question paper? The recent question paper, whichever you wrote the one most recently. Can you send me the question paper?
What's up, sir?
Sorry, I'm asking you the question paper. Can you just send me the question paper? We'll discuss it now. That question paper we'll discuss now. Everybody go and take the question paper with you. Or anyways, I'm going to show you the question paper. No problem. Yeah, got it. So let me download this. Okay, all right. So let me share my screen. I have downloaded the paper. Okay. I hope everybody is able to see the screen. Okay, so obviously we'll discuss only the chemistry part. Okay, right. The first question. Right. The setting of plaster of Paris takes place due to, what is the answer, guys? What is the answer? Setting of plaster of Paris takes place due to what? Any guesses? What did you answer in the exams for this question? Hello? Are you guys there? Am I on mute? No, right? Are you able to hear me speaking, people? Guys, are you there? Are you able to hear me speaking?
Yes.
Okay. Yes. Fine. So yeah, what will be the guess for the first question? The
Sir,
setting of
hydration.
Sorry. What was it?
Sir, I had written it as hydration.
Hydration. Okay. See, what is plaster of Paris formula? POP's formula is what? What is the formula for POP? Plaster of Paris. What is the formula? Nobody knows. What is the formula for plaster of Paris? Okay. So plaster of Paris is calcium sulfate hemihydrate. Okay, CaSO4 dot half H2O is what is my plaster of Paris. Correct. Right. So this Now, see, remember that this will be very soft. Okay, this will be very soft. So when it has to set, okay, when it has to set, it has to get converted into CaSO4.2H2O. That is your gypsum. Okay, and this is hard. Okay, so it is like cement. Cement will be initially wet, right? And then eventually what happens? It becomes hard. So cement initially is soft, and eventually after some time it will become harder, right? Same thing only is happening with the plaster of Paris also. Initially it is soft, right? And it has to become hard, right? And what do you have to do? Obviously, I have to add water to this. So that half H2O becomes 2H2O. Okay, half H2O becomes 2H2O. So can I tell, obviously the answer to this question is hydration. What is hydration? Hydration is addition of water. Okay, so if you add water to plaster of Paris, that is CaSO4.half H2O, it will set, it will become stronger after a point to become CaSO4.2H2O. That is nothing but gypsum. And what are you adding? You're adding water to this. So that kind of reaction is what is called as hydration. Everybody understood why is it hydration? Can I get a yes from everyone?
Yes, sir.
Yeah, I said everyone. Only one yes I'm getting. Are you guys okay, people? Let me call out names. Then only it'll be fine. Okay. Atharva, I think Harita was the one who spoke now. Janvi, Fuja, Aditi,
Yes.
Everybody's okay?
Yes, sir.
Okay, good, good. Right. I know it's Sunday morning. I know you must be sleeping, but still you woke up for me. It's completely all right. Right. This is not the first time you're doing this. Correct. Okay. Next question. Right. The chemical formula of baking soda. Okay.
Sir, NaHCO3.
Very simple, right? This question, right? We all know baking soda is NaHCO3. What is washing soda's formula? If I ask you for the same question, if it was washing soda, what you would have answered? If it was washing soda, what would have been the answer to this question? We discussed, right, in class, washing soda, baking soda, all that. Okay, so washing soda is Na2CO3. That is here, right? This is washing soda. Okay, right. Anyways, next question. The basic nature, third question. The basic nature of sodium hydroxide is due to the presence of dash in solution. What is the answer? When I dissolve, now we know there is something called as Arrhenius theory. Right? There is something called as Arrhenius theory of acids and bases. Right? What does Arrhenius theory says? How do you define an acid? How do you define a base with respect to Arrhenius theory? Can someone tell me? Go on. How do you define acid or a base? Go on, people. How do you define acid or a base? What is an acid? What is the base?
Acid produces hydrogen ions in
just
water.
Like that? Just like that H plus? Or anything before that should come? Okay, that is anything which dissolves in water and gives me H plus, right? First, the species has to dissolve in water. That is the first step. Okay, anything which dissolves in water and gives me H plus is what is called as an acid, right? And anything which dissolves in water and gives me OH minus is what is called as a base. Okay, so now they're asking the basic nature of sodium hydroxide is due to the presence of what ion? What are the ions responsible for this? What did I tell you now for a base? Anything which dissolves in water and
Hydroxide ion.
gives me OH minus, right? OH minus is what is my base, right? And what is this OH minus ion name? This is what is called as hydroxide ion, right? This OH minus is what is called as hydroxide. That's why it's called sodium hydroxide. Okay, so the answer to this question is option D, a hydroxide ion. The basic nature of sodium hydroxide is due to the presence of hydroxide ions in solution. In solution means they're asking about water. Okay, right. Next question. The aqueous solution with pH equal to 0 is what? Is it amphoteric, neutral, acidic, basic? What is it?
Acidic.
Sorry, what is it?
Acidic.
I don't know what you said, but the correct answer would be acidic, right? Correct. So because 0 to 7, it is acidic. At 7, it is neutral, right? And 7 to 14, it is basic, right? This is how we understood pH, right? pH scale between 0 to 6, I would say 0 to 7 is an acid. At exactly 7, it is a neutral, and from 7 to 14, it is going to become basic. No problem. Okay, next. The pH of the gastric juices released during digestion. The question number 5 I'm talking about, right? The pH of gastric juices released during digestion is what?
Less than 7.
Less than 7.
Definitely, we know that in for digestion, it is going to be the acids which are secreted in the for digestion, right? The gastric juices they are talking about are nothing but acids. Okay, the gastric juices they're talking about is nothing but acids. So definitely we know for acids the pH should be lesser than 7. Okay, so the correct answer to the question is less than 7, option D. Okay, next question, question number 6. Which of the phenomena occur when a small amount of acid is added to water? Ionization, will it happen?
Yes, sir.
Okay, it happens, right? For example, if I dissolve HCl gas in water, I know I'm going to produce HCl aqueous, right? This HCl aqueous I know will give me H plus plus Cl minus. So what is happening here? This compound is getting converted into ion. This process can be called as ionization. Yes, no problem. Because a compound is getting dissociated to form ions, right? So yes, I can call this as ionization. Okay. Neutralization, no. For neutralization, I need a base, not water, right? Dilution, yes. If the acid is added to water, that is how we dilute it, right? We add acid to water, drop by drop, not the other way around, right? We don't add water to acid for dilution. We know the reasons, because it will be very violently explosive. Okay, so yes, dilution can be the answer, right? Salt formation, no. Again, for salt formation, I need a base, right? For salt formation, we need a base. So 1 and 3 are the only correct answers. The correct option to this question is option A, 1 and 3, ionization and dilution. Okay, ionization and dilution is the answer to this question. Okay, next. Dilute hydrochloric acid. Okay, dilute hydrochloric acid was added to solid sodium bicarbonate, right? Let me write the formulas for you. They're asking about hydrochloric acid, dilute hydrochloric acid, HCl, and the other one is sodium bicarbonate. Can someone tell me what is the formula for sodium bicarbonate?
NaHCO3.
NaHCO3, sodium bicarbonate. Okay, now how will you complete the reaction? Can you complete this reaction? HCl plus NaHCO3 will give me what? Right. See, please understand, this is an acid. Okay, this is a base, right? But a weak base. right? So generally when an acid plus base react, we all know it's a neutralization reaction to form salt and water. Okay. But when I have an acid which is reacting with a bicarbonate or a carbonate, bicarbonate or a carbonate, that is Na2CO3, right? Carbonate or bicarbonate. What you have to understand is, people, you will have neutralization. That is, you will have salt, you will have H2O. But since it is bicarbonate, one extra thing will come. That is, your CO2 will also be formed. Carbon dioxide gas will also be evolved. Okay. If it is normal acid plus base, salt plus water is what is getting formed. But if the base used is a bicarbonate, okay, if the base used is a bicarbonate or a carbonate for that matter, you will have salt plus water, but extra you will have CO2 formation also. Okay, so the correct answer to this question, how will I complete this reaction? I know the salt would be NaCl, sorry, not HCl, NaCl. Okay, plus water, right? Obviously, since it is acid, this is a bicarbonate, I will have carbon dioxide gas also. Okay, so look at the options, right? A gas is evolved with a pop sound. For pop sound, what is the gas, people? What is the gas associated with pop sound?
Hydrogen.
Hydrogen.
Hydrogen, right? Pop sound is given by hydrogen. So that is not the answer, right? So fine. Next, the color is yellow. No, nothing like that. Okay, the color will still be colorless only. Basically, all I have is NaCl, right? NaCl solution, aqueous solution. I know this is colorless. Okay, so C also cannot be the answer. So A cannot be the answer. C cannot be the answer. Let us look at option B. Gas evolved. Okay, gas is evolved. Fine, and a black residue appeared at the bottom of the test tube. Nothing like that. Nothing like that. Right. Next, a brisk effervescence was produced. Yes, this brisk effervescence is because of the production of CO2. Okay, brisk effervescence means like something is coming out. You can see what is effervescence. Maybe just type effervescence in Google. You'll understand what is effervescence is. Okay, effervescence means in Tamil pongi varadu. Like it's something like it's coming out with that fuzzing sounds like that. Okay, that is what is happening because of the production of CO2. Because it's a bicarbonate, CO2 is produced, so a brisk effervescence is produced. So the correct answer to this question is option B. Okay, next question. Which of the following is true for acids? Yes, can you just read this one and tell me what is true? Okay, is it sour? Yes, go
Yes,
on. What is
sir.
the answer?
Sour taste and change blue litmus to red.
Very simple, right? I know acids are sour in taste, right? And they change blue litmus to red. Blue litmus to red. I think the correct answer is there in option B. Right? It is sour and it changes blue litmus to red. Okay, right. Next, which of the following is used for dissolution? Dissolution means dissolving of gold. What is used? We have already discussed this so many times in the class. What is the answer to this question?
Aqua regia.
Yes, aqua regia. Normal acids will not be able to dissolve gold. I know aqua regia is a combination of HCl plus HNO3. Is it not? It is a combination of hydrochloric acid and nitric acid. Some combination in some amount, right? That forms aqua regia. That is a very strong acid which can even dissolve gold. Good, good. Right, next. A metal, look at this. Next question. Metal which is liquid at room temperature. What is the answer?
Mercury.
Okay, that's an assumption, right? We generally know metals are hard solids, right? Only one of them is liquid at room temperature, that is 25 degrees Celsius. At normal conditions, it is still a liquid. I know the famous liquid metal is nothing but mercury. That is why we go for temperature. I mean, that is why we use mercury in thermometers, right? Since it's a liquid. Anyways, okay. Next, which of the following can undergo a chemical reaction? I think they're asking about what? Displacement reaction, right? Now look at the options. All the options A, B, C, D. Some salt is there, some metal is there, right? So we know displacement reaction will happen if the metal is more reactive than the metal in the salt. Okay, think about this and tell me what will be the answer. Yes, people? Okay, CuSO4 and Fe. Now look at this. So for this reaction to happen, what it should be? Fe should be more reactive than copper, right? Okay, for this reaction to happen, basically I should form FeSO4 plus Cu. That's what I should expecting. Iron should be more reactive than copper. Is it correct? Is iron more reactive than copper?
No.
It is. It is. Iron is more reactive than copper. Okay, and copper is less reactive than hydrogen. Okay, fine. Anyways, if you're not able to understand this, we'll look at the other ones. Okay, now I need zinc to be less reactive than iron. Is it correct? Only then this will happen, right? For this reaction to happen, iron should be more reactive than zinc. Is it possible? Is it correct? Iron more reactive than zinc. Correct or not? No, it's not. Right? See, I don't know what is taking you so long, right, guys? This is the reactivity order: potassium, sodium, calcium, magnesium, zinc, aluminium, Fe, hydrogen, copper, silver, gold. All this. This is the reactivity order. This is Fe. Okay, and obviously before zinc and aluminium comes your lead also. Okay, Pb. Okay, right? So this is the reactivity order. Now you can see that iron is more reactive than copper, but it is less reactive than zinc, right? So this reaction will not happen. That is B will not happen. Mg and Fe. See, where is Mg? Mg is here. Fe is here. Again, Fe is less reactive than this Mg. So this reaction also won't happen. Mg and Pb. Again, you can see, right? Mg is here, right? Pb is here. Mg is more reactive than Pb. That is lead, right? So definitely this reaction also won't happen. But copper and iron, yes, iron is more reactive than copper. So this reaction will happen. So the correct answer to this question is option A. Okay, I hope everybody is following. Okay, next question. Question number 12. Right. An element A, okay, there's some element A is soft and can be cut with a knife. This is enough. What is the answer to this question? Which is the element? An element A is soft and can be cut with knife. What is the element?
Potassium and sodium.
Exactly. Potassium and sodium. I don't have potassium here. I have only sodium. The correct answer to this question is option A, sodium. Okay. Obviously, the other statements are also correct. This is very reactive to air, right? And it cannot be kept open because it will react with oxygen atmosphere. It reacts vigorously with water. Yes, we all know this, right? But the first statement was enough for me to answer the question. That is sodium. Okay. Next question. Electrical wires. Okay. Electrical wires have a coating of insulating material. The material generally used is what? Okay, you know that inside, if you see a wire, right? If you see a wire, there'll be this insulation part, and then only this wire will be there. Okay, this is the wire, right? And this is my insulating part. Insulation part is because when I'm touching the wire, I should not be touching the conductor so that I won't get hurt. Right? That's why any wire you will see that it will be insulated. You must have seen this, right? What is the material used generally even though this question should not be asked, right? But still, I think you can answer this question. What is it? What is this insulating material? You can look at the option and answer this. Okay, first question, can graphite be the answer? This insulating material, can graphite be an insulating material? Yes or no? Can graphite be the insulating material? Yes or no?
No, sir.
No. Why?
Graphite is a conductor.
Exactly. Graphite is already a conductor. Right? So I will not be able to use the insulating material. Right? Fine. Now, so obviously the answer can be either sulfur or PVC. What do you think will be the answer? What will be your guess to this answer? Is PVC or sulfur?
PVC.
Yes, you must have seen so many times in your ads, right? Your PVC, polyvinyl chloride is a full form, right? PVC is the one which will be insulating material in all the wires, not sulfur. Okay, I don't know how many times you have seen the ads, right? Your what I don't know. I now I'm not remembering any wires' names. Say Phenol-X. Phenol-X are the wires, no, right? Okay, so any wires ad you take, right? You will see that they will have mentioned this. It's the PVC wire. PVC wire means its insulated material is PVC. Okay, fine. Now look at this question, 14th question, right? Fe2O3 plus C gives Fe plus CO. In the given reaction, C acts as what? Okay. Now we all know what is oxidation, what is reduction, what is oxidizing agent, and what is reducing agent. Okay. Now look at this reaction and properly tell me what is happening to Fe2O3. Is it getting oxidized or reduced? Fe2O3 is oxidized or reduced. Look at the equation carefully and tell me. Okay, now you look at the reactant Fe2O3, it was with oxygen, right? It was with oxygen. And what is happening to iron in the product side? I have removed oxygen, is it not? Right? In the reactant side, iron was with oxygen, right? And in the product side, only iron is there, oxygen is not there. So iron is what? Iron is reduced. Yes. Why? Because from iron, I have removed oxygen, right? I have removed oxygen. Fe2O3 becomes Fe. I have removed oxygen, so iron is reduced. Okay, right. Now look at carbon, right? Carbon is becoming CO, right? So carbon is carbon had nothing in the reactant side. Now carbon is with oxygen in the product side, right? So can I say carbon is getting? Yes, go on. Carbon is getting what? Carbon is undergoing oxidation. Okay, iron, from iron I'm removing oxygen, so it is a reduction. From carbon to carbon, I'm adding oxygen because CO, right? Carbon is becoming CO, carbon monoxide, right? So I'm adding oxygen to carbon, so carbon is the one which is getting reduced, right? And we all know, people, whichever is undergoing reduction is my oxidizing agent, right? And whichever is undergoing oxidation is my reducing agent. Okay, whichever is undergoing oxidation is my reducing agent, vice versa. Whichever is getting reduced is my oxidizing agent, right? So keeping that in mind, they're asking about carbon here. Okay, now I know carbon is undergoing oxidation, so it will be a reducing agent. Okay, it will be a reducing agent, right? Excuse me. Okay, next question. Question number 15. Right? Although metal forms basic oxide, which of the metals form an amphoteric oxide? We have discussed this so many times. What is the answer to this question? Which metal forms amphoteric oxide?
Aluminium, sir.
Yes, that's it. Aluminium and zinc. That's it. Only two elements are possible. Right? So the answer to this question is aluminium, option A. Okay, next. The ringing of the bell. The ringing of the bell in temple is associated with which property of the metal? Which property? Quickly, quick. What is the answer? Ringing of the bell.
Sonorous.
Yes, sonorous, producing sound. Right? All metals, when struck, will produce a sound. Right? And that property is what is called as being sonorous. Okay, good. Right? Next. Which one of the following elements symbolized as A and B is a metal? Right? Which one is a metal? Now see, this is how the representation of metal is. Whatever. Now let me tell you this. Okay, I write some letter, some A, right, and I write the mass number on the top, atomic number on the bottom. Okay, you have to remember this. Okay, mass number on the top, atomic number on the bottom. For example, I'll write chlorine as 35.5 and 17. I write like this. Right? This is your mass number. This is your atomic number. Okay, like for example, sodium, I'll write 23, 11. 23 is the atomic mass number and 11 is the atomic number. Okay, so obviously if you want to decide whether something, you have to take only the atomic number and write the electronic configuration. Okay, right. So now you can ask this question. Where is it? Okay, so A with 23 and 11. Oh, okay, this is sodium, right? Okay, next I have B with 40 and 20. Okay, let me write this. Okay, so I have A with 23 and 11 and with B as 40 and 20. Okay, and they want to know whether it's a metal or a non-metal. Now, please understand, people, metals are electropositive in nature. What is being electropositive? They form cations, right? And for forming cations, they have to lose electrons. Okay, so many informations are written here, right? Metals, we would tell that they are, right? We will tell that they are highly electropositive in nature. What do you mean by being electropositive? They form positive charge, right? They convert themselves into positive charges. That means they form cations. How do they form cation? Obviously by losing electron, right? So by looking at the electronic configuration, if you can decide that they can lose electron, then definitely we can be sure that they can be a metal. Okay, so now I have 11. How will you write the configuration? 2, 8, 1, right? And how will you write the configuration here? 2, 8, 8, 2. Okay, now it's very easy for both of them to lose electron because at the valence shell, I have only 1 electron. I have only 2 electrons. But if I had a configuration like 2, 8, 7, for example, obviously I cannot remove 7 electron. All I can do is add 1 electron and make octet satisfied. Right? So this would not be a metal if I had 2, 8, 7. I know it's only chlorine. Right? But in this case, I just have to remove 1 electron and 2 electrons from the valence shell. So both of them can be metals. Okay, both of them can be metals. Right? So the correct answer to this question would be both A and B are metals. Is the answer to this question. I hope everybody is following. It all depends on the electronic configuration, nothing else. Right? Okay, next. Match the following with the correct response. Okay, bronze. Bronze is made up of what? Copper. Okay, it is an alloy, right? All these are alloys. Even though we didn't speak about this, then you can easily remember it. Okay, bronze is going to be copper. So bronze is made up out of copper. Okay, stainless steel, right? Stainless steel is made out of iron. Okay, now duralumin, from the name itself you can understand, duralumin is aluminium, right? And solder is the only thing left out, and that is tin and lead, right? So what A goes to D. That is 1D. 1D, where do I have? 1D is right there. This is the only option where I have 1D. I'll do the other option. 2 is going to A. 2 is going to A. 3 is going to C. Salter is going to C. Yes, definitely. Right. And duralumin 4 is going to B. So yeah, the correct answer to this question is option A. Okay. I think these are all the chemistry questions, people. Okay. Did you have any doubt? Any questions anybody has? Any questions anybody has? Okay, fine. If that's the case, I think we can stop right here. Okay. So the agenda of the day was to discuss only the question papers. Okay, and we did. Right. Okay. Okay. Any further questions anybody has? Anybody wants to teach me anything? I mean, anybody wants to teach you anything for that matter? Sir, this I have doubt. This, can you teach me anything of that sort? Okay, fine then. Thank you so much, people. We'll meet again next week. I'm ending the class.
Sir, one doubt, sir.
Yeah, go on.
Sir, what do you mean by brisk effervescence, sir?
Oh, brisk effervescence. Okay, let me show you a video for that. Okay. I'll share my screen.
Hello everybody and welcome to my channel.
I just want a small I just want a small brisk effort. Brisk, not brisk. No. I just want to show you what is brisk effervescence. Exactly the thing they took H2SO4 plus NaHCO3. Right? So basically I have, in the question I asked you, they asked about H2SO4 plus NaHCO3, right? Look at this.
Hello everybody and welcome to my channel. Today I will demonstrate what is brisk effervescence, how it occurs, and a lot about it. So let us come to the procedure. So I am just shaking it, the water level you can understand. Very little. Now in a test tube, we have to give some sulfuric acid. I am using sulfuric acid. You can use any acid with it.
Any acid.
So
okay.
This is my sulfuric acid bottle. Now I will just give some drops of sulfuric acid in this test tube.
Look at what look at what is going to happen. Okay, it's taking sulfuric acid. Already I have sodium carbonate in that.
So I am done now. I will give this sulfuric acid in the test tube to the beaker of water I have added to just dilute the sulfur. So I have added.
Okay. This is baking soda.
The chemical formula of baking soda is known to all, that is
NaHCO3, right? NaHCO3. Now I already have H2SO4 in the beaker. Okay.
Now my question is, what will happen?
We know what is going to happen. We know the reaction. We'll see.
Add.
Now see, that is what is brisk acid. Pongi or that exactly you saw. One more time, I'll show you. Look at that. That is what is brisk effervescence. Okay, the moment you add it, evolution of CO2 is going to happen, and that is going to be very fast. Big bubble. See one more time. See that. This is exactly what is brisk effervescence.
Wow, it's so amazing, isn't it?
Right.
It's very smoky here. I will just suggest you not.
Okay, sir.
Understood. Okay, that is what is
understood.
Okay, right. Any other questions anybody has? Okay, thank you so much, people. We'll meet again next week.
Thank you, sir.
Thank you, sir.
Thank you, everybody.